Hi, I'm Cheryl Leach. In this problem, we're going to approximate the area of the region bounded by my function x times the square root of x plus 4 and the x-axis from 0 to 1 using 5 rectangles. All right, well the first thing we need to do is to get a sketch of this graph. You already have techniques that you've learned in previous sections to talk about when a graph is increasing, decreasing, concave up and concave down. I've already worked on some of this material for you, and I know that this particular function doesn't have a change in increasing and decreasing and does not have a change in concavity on the interval from 0 to 1. And so I know that the function is strictly increasing and concave up on that interval. So I have all of this information ready to go. So I know that the point 0, 0 is on my curve, which is right here, and the point 1 and the square root of 5, which is about 2.24. So that will be right about here. I know my function's increasing and it's concave up, so it's roughly going to be looking like that. All right, so now we need to concentrate on finding those rectangles that I'm going to use to approximate the area under this curve. Well, the first thing I want to do is look at the width. What should the width of these rectangles be? Well, I know I calculate my width by taking b minus a and dividing it by the number of rectangles I want to use. In this case, the length of my interval will be calculated by 1 minus 0. And because I'm told that I want to use 5 rectangles, I'll divide by 5. So each rectangle will have a width of 1/5. So I'm going to start at 0 and I'll move to 1/5, then 2/5, 3/5, 4/5, and then 5/5 takes me to that right endpoint. All right, so now I have the widths of my rectangles marked off. But I also need the height of those rectangles. What I'm going to do is I'm going to use the midpoint to find the height. So I'm going to look at my first interval. My first interval goes from 0 to 1/5. I'd like to find the midpoint of that interval. So I'm going to add these 2 points together and divide by 2. That gives me a midpoint of 1/10. That's going to determine how tall I should make my rectangle. Now remember, 1/10 is not the height of my rectangle. It's going to be f of 1/10. So the height is f of 1/10, which in this particular problem is going to be 1/10 times the square root of 4.1, because that's 4 plus 1/10. My next interval is going to be the interval from 1/5 to 2/5. And again, I need to find the midpoint. So I'll add these two together, that gives me 3/5, and then divide by 2. So that leaves me with 3/10. So 3/10 is going to be the midpoint of that interval. To calculate the height of my rectangle, I want to take f of 3/5, or 3/10. So f of 3/10 is going to be 3/10 times the square root of 4 plus 3/10. Well, that's the square root of 4.3. Repeating the process for my third rectangle. I'm going to be moving on the interval from 2/5 to 3/5. That's this interval. My midpoint, I'll calculate by adding these two numbers together. So that's 5/5 divided by 2, which is going to be 1/2. And again, the height is going to be f of that value. So I'm going to have f of 1/2, which is 1/2 times the square root of 4 plus 1/2, or in other words, 4.5. Fourth rectangle, the interval I'm looking at is 3/5 to 4/5. The midpoint will be the sum of those two numbers, so that'll be 7/5 divided by 2, so that's going to give me 7/10. And the height will be f of 7/10. Or in other words, 0.7 times the square root of 4.7. And that gives me my fourth rectangle. Last rectangle, my interval is 4/5 to 1. And I want to look at the midpoint. So I'll look at the midpoint, and that's going to happen when I add these two together, so that'll be 9/5 divided by 2 is 9/10. And f of 9/10 is going to be 0.9 times the square root of 4.9. And that gives me the height of my last rectangle. Okay, I have all the pieces put together now. I have all the individual pieces. I need to put them together now. So my area of all of those rectangles will be the area of each of the individual rectangles. And then I need to add them together. Well, my first rectangle, remember the width is always 1/5, will be 1/5 times f of 1/10. Because that's the height of my first rectangle. For the second rectangle, the width is once again 1/5. The height this time is going to be f of 3/10, because 3/10 was my midpoint. For my third rectangle, the width is once again 1/5. The height is going to be the function value when I plug in 1/2. For my fourth rectangle, a width of 1/5 again. This time, the height is going to happen when the input is 7/10. And for my last rectangle, I have a width of 1/5. The height happens when that midpoint is 9/10. Okay, now I have some number crunching to do. I do notice that there's a 1/5 in every one of those terms, so I can factor that out. And I'm going to go ahead and evaluate these functions. F of 1/10, I've already discovered, is the square root of 4.1 divided by 10. Again, I factored out the 1/5, and f of 3/10 is going to be 3 times the square root of 4.3 all over 10. For the third piece, again, the 1/5 gets factored out, and I will have the square root of 4.5 all over 2. The fourth rectangle, the 1/5 is pulled out, and I'm going to have 7/10 times the square root of 4.7. And then the final one, the 1/5 is pulled out, and I'm going to have 9/10 times the square root of 4.9. Now, at this point, you may wish to pull out your calculator to do a little number crunching. So I'm going to sum up the square root of 4.1 divided by 10 plus 3 times the square root of 4.3 divided by 10 plus the square root of 4.5 divided by 2 plus 7 times the square root of 4.7 all divided by 10 plus 9 times the square root of 4.9 divided by 10. And your result will be approximately 5.395. We can take that number and then divide it by 5. So I have 5.395 divided by 5, and I get 1.079. Now, that's the area of my 4 rectangles added together. The actual problem asked me to find the area bounded by that curve. And so the area, which is equal to the integral from 0 to 1 of x times the square root of x plus 4 dx, is approximately equal to 1.079. I hope this was helpful. Thanks.